Hello folks, and welcome back to the shop. So, I want to talk to you about something, which is that for some time now I've been thinking about making daily vlog videos, and I think that's what I'm gonna do now. You may have noticed that I don't put out many quality edited videos anymore, and that's because I just haven't found the time and motivation to do it. I have lots of material to be edited, but I don't know when I'm gonna do it. So anyways, I think from now on I will try to put out these kind of vlog videos whenever I feel like it, which will most probably be almost every day, maybe except for the weekends. And why? Well, because I kind of like it. I like making videos. I just don't like the editing work, because I don't like sitting at my computer. I like to do some real things like this. So you can let me know what you think about this plan. And as I make these videos, please feel free to comment once again and tell me how you feel about the videos that I make. So, but I think if I make the daily vlogs, they will provide you with way more interesting content that I have provided you until now. It's just gonna be in a little bit more rough form. So anyways, there is one problem. Please help me think out a name for my daily vlogs. For example, John Saunders at NYCCNC has Chip Break and Wednesday Widget and whatever other ones he has. And he's making awesome videos, by the way. So please help me think out a name for my daily vlogs. So this would be a daily vlog number 1, except that it will not be a daily vlog after you have helped me with thinking out the name. And please make some suggestions, but the winner is gonna be chosen by me. So I think let's get straight to it. Well, one more thing about the vlogs. I have a tendency to make pretty long videos, as you may have noticed. So from now on I will try to give you the most interesting things first, and then if you want to, you can watch the whole video and listen to my speech about whatever I have to talk about. So let's start about the CNC lathe once again, which is been doing some work today as well. I have my first soft jaws made. I just used some old used soft jaws that came with the machine, that I could use, that were the correct size. And the benefit of using soft jaws for this job is that I can have a accurate backstop, so I can just stick the piece in and close the jaws, and it's gonna be very accurately in the chuck with almost no run out at all. And I'm making pieces like this, just a very simple, I think it would be called some type of a bushing maybe, and it's gonna be welded into this piece, which I still haven't made, with an internal thread. I will make it as well, and I will show it to you. But this is what I'm making now, minus the threads. And what this actually is, it's just a bushing, and the ID is a little bit undersized, because they will ream it after they have welded it. And by the way, do you like this weld scene? I think it's pretty awesome. It's really heavy welding. So yeah, and that's what I'm making now. I still have to chamfer these edges, and these are not beautiful in any means, but that's just fine. So maybe I can show you how to make one, so you get to see some action actually. I'm tucking these in so that the parting side, which I used to part this like this last time, I'm gonna flip it around now. So it's kind of facing it a little bit, but actually this piece is already pretty short, and I don't want to make it any shorter, so it's not actually removing anything from the face. It would have made it look better, but this finish is actually just fine for what it is, and even though it looks a little bit rough, it's actually pretty smooth. But it is finishing this chamfer right here. So after each part I'm using my finger, usually with gloves, to wipe out some chips from inside the chuck, and then just put it in the soft jaws and press the foot pedal to close the chuck, and it's now in there very firmly. And this operation is only using two tools. One is the Tagutech WNMG, and the second one is this 1/4 inch or 20mm boring bar, which holds a TNMG insert, which has a pretty positive geometry. And I got quite a bit of an overhang right here. It's like 4 times diameter, which is very much, but it's actually doing fine now. I have to do some testing with feeds and speeds, but at the moment I'm very happy about how it runs. So let me show it to you. Cycle start. So first it's finishing the face and the chamfer. And now it's boring. I think it sounds pretty good. It's not totally silent, but I think there's no way to get it any more quiet than this. So running at 740 RPM and feed rate of like 0.2 millimeters per revolution, I have the feed rate overrode by 10%. So really slow on speed and pretty fast on feed to avoid vibration. And I noticed one more problem with the lathe is that the window is leaking coolant pretty radically actually, so I'll have to seal that up. And the knocking sound that you hear is from here. So this cover is hitting the rotating spindle. I think it's missing a few fastening screws. It sounds pretty nasty, but that's just the cover hitting the spindle. And this is the finished part. The cycle time is 130 seconds, so 2 minutes and 10 seconds. And so it's pretty quick. And it's making really nice chips. Really happy about that. The worst problem that I had with the boring bar was that the chips would not break and they would jam up in the hole in the bore, I mean. Actually, I was supposed to first just use the U-drill to bore the starting hole, which I actually did, and it worked beautifully, even though it's using the whole length of the U-drill, which is 70 millimeters plus a few millimeters, and then offset it to enlarge the bore. But I just couldn't get the chips to evacuate from using the U-drill and such a deep blind hole. So I'll just have to do it like this and turn it around and do operation number 2 with a different tool. So chip evacuation is a huge issue on mass production. Seems to be, at least for me. if I had a higher pressure coolant, maybe that would blow the tips away, but I don't have it, so gotta use what you have. So something more that I'm gonna do the next days is 508 pieces of these crowbars, and it's gonna get a slight sharpening to one end by milling, and then it's gonna get turned on a lathe on the other side to a pretty sharp angle with a blunt point. And after machining, it's gonna go to bending and some kind of sandblasting. And this is a finished product. It's just a sample piece. So I want to do the taper in the CNC lathe, but how are you gonna hold stock like this in a 3-jaw chuck? And I spent some time figuring that out, and there are pretty much 3 ways to do it. And one would be to make soft jaws with the kind of notches that take this particular shape, and maybe I could have one of the jaws adjustable, so that I could dial the stuff in, the stock in. But it's really difficult to cut the soft jaws accurately enough. So I was going to do that, but after all I didn't. And the second option would be to have a collet in the 3-jaw, self-made collet, that would have this rectangular shape. So I was thinking I could turn the collet myself and then have it wire EDM'd to the correct shape and slit it, and that maybe would have been the best option of these all, maybe pretty much as good as the soft jaws, but maybe with a little bit less effort. But EDMing is so expensive that I just decided to go with a round collet that has the same ID as this rectangular stock has its max diameter anywhere. So right now this is fitting pretty closely inside this collet, and by trial and error I figured out the correct width for the slit, and also the correct thickness for the wall. I mean the wall thickness right here, so that by using the pressure that I have on the hydraulic chuck at the moment, it's pressing the right amount, meaning that it's not crushing the corners of this piece, but it's still having enough force for the workpiece to be very rigid. And I'm actually extremely happy about how this came out. So it seems to be working perfectly. Well, I still haven't turned a single one of those crowbars, but from the tests that I made, it seems to be working really well. And you can see I've got quite a few of these pieces, and these are a little bit different. They're not gonna get a taper, it's just sharpening by milling on each end. But then I have some more, a little bit larger, like these, with 30 by 30 stock, I mean square stock. I need to make another collet for them with exactly the same idea. I got like 200 or 300 of those, so lots of work to do. It's simple production work, but it pays pretty good money. And the manual milling machine is set up for milling the sharp edge. So I have the universal head set up in the correct angle, and I still have to attach the milling head and then just start making a huge amount of chips. So yeah, and something else that's going on here. Well, maybe I can show you this. Well, this came in today. It's an alloy rim, car rim, with a little bit of a problem. So it completely lost the control arm ball joint, and the arm put a hole in the wheel, which is a little bit bad. But I think I'm gonna be able to fix it quite good. And always when I do aluminum rim repairs by welding, I make sure that the customer understands that the rim will not be completely as strong as it is when it's new. Because when you weld aluminum, especially cast aluminum, it's always gonna get a little bit soft. But I have never heard of anyone having problems with welded rims. And one more thing, I have this huge stock of aluminum. It's actually 300 millimeters in diameter. This is a huge chunk of aluminum. It weighs like 200 kilograms or 500 pounds. Don't ask me where I got it. It's another story for another time. And I finally got some use for it. It's now got this piece sawed out of it, and I'm gonna make a hub to fit this wheel. This is a forklift wheel actually, and I'm gonna make a hub for it, for 2 bearings. Something like this. And what was pretty funny, I have another shop locally, local shop right here, which mostly does welding and fabrication work, not so much machining. So we're actually pretty good partners. I'm making lots of parts for them. They have a huge metal cutting bandsaw, and since I needed a piece cut off from this piece, I asked them to saw it for me. And they have a small truck with a high-up crane, and they came to pick up this a few days ago, and today he got it chopped off, and he brought it here by a forklift, a tiny forklift, which is luckily registered for road use. So it was quite funny to see the machinist came here. It's like a 2 kilometers or 1.5 miles, or a little over a mile, to drive on a tiny little forklift. So that was pretty funny, seeing that come on my yard. And we were a little bit unlucky with the forklift actually. Usually downhill is okay, but uphill is not so easy. So what happened is that even though the forklift was small, it still weighed like 4.5 metric tons. And of course the back wheels wanted to sink in the ground, and its belly was scratching the ground, and of course it got stuck. So we had to pull it out, but it all went fine after all. If we hadn't driven it down my ramp here, it certainly wouldn't have been any issue at all. It's pretty easy to kick around this heavy piece just by doing this, even though it's so heavy. So, some pretty interesting stuff to come. And yeah, I think this is finally the end of the vlog. I tried to cover the most important and most interesting things first, and just pointless bits at the end. So if you want to watch, you can do it. Okay, I think it's hopefully until tomorrow I will upload this video now. So please let me tell you, please let me know what you think about this kind of videos, and please give me suggestions for the name for the vlog series. So, thank you very much for watching and please leave comments. Okay, thanks for watching. Until next time.